All right, we're going to take a look at solving systems of linear inequalities, and we're going to use those to solve problems. For example, here we have boats. We have aluminum and fiberglass boats. So the first thing I did was I declared some variables. I said X is going to be equal to aluminum and Y is equal to fiberglass. You could use whatever letters you want. I like to use X and Y because they correspond to our X and Y axes. All right. And then it says, when both assembly lines are running at full capacity, a maximum of 20 boats can be made in a day. So X plus Y is going to be less than or equal to 20. So the number of boats altogether has to be less than or equal to 20. Now what I did was I immediately turned that into a equation that we can graph. So I subtracted X from both sides. I got Y is less than 20 minus X. And then we keep reading. The demand for fiberglass is greater than the demand for aluminum, so the company makes at least 5 more fiberglass boats than aluminum boats each day. So if we take the number of aluminum boats and add 5, that will be less than or equal to the number of fiberglass boats, right? The number of fiberglass boats is going to be bigger than the number of aluminum boats. So I just rewrote that. Y is greater than X plus 5. So now that we have two equations that we can graph, we do that. I don't have my pretend ruler handy, so I kind of freestyled it. This is the first one, 20 minus X. We know 20 is our y-intercept, and we know our slope is -1, so it's going to go down to there. Because we have the little is equal to underneath, we don't have to worry about a dashed line. So then we take a look at our second one, y is greater than x plus 5. Our y-intercept is 5, so we drew that over there. Slope is 1, so we freestyled a drawing here with the green line. And then we took a look at some of our restrictions. X must be greater than or equal to 0. Y must be greater than or equal to 0, right? We can't have negative boats. I plonked them into the integers. We could put them into the whole numbers. Doesn't really matter, as long as you're not putting them in the reals. So then I took a test point for each graph, and I chose point 2, 2. In this case, because 0, 0 is kind of on that boundary, you can't really use it. So I just took the next closest, and I took 2, 2. So I plonked that into our first graph, or our first equation, and we got 2 is less than or equal to 18. This is in fact true. So I shaded the area with that test point in red over here. Then I took that same test point and I applied it to our second graph, the green line here, and found out that no, that test point isn't in the solution space. So I had to shade in green the area above the line here. So now any point within this triangle here will be a solution for our problem here about the boats. So I took this point here, 212, that is a possible solution. I also took this point here, 412, it's a possible solution. Now, because this is a whole number answer, whole number question, we should actually stipple our graph. So these are two possible solutions for the number of boats being made.